Hello class, and welcome to our Chapter 7 final review. So the first thing that we're going to be looking at is how to identify an unknown variable, something we don't know. So let's look at this problem for an example. The student council is holding a car wash to raise money. They are charging $7 for each car they wash. So we need to know something. Now, what we want to know is how much money they raise total, as we know. But what is the variable? What makes a difference? What is changing how much money they make? So in the end, this is our dependent variable, right? The dependent variable means that it relies on the independent variable, and that would be our variable. So, for example, what don't we know here? What don't we know? So what we don't know is how many cars they wash. We don't know that. So let's say I said and honestly it could actually go either way, because if I said they washed 7 cars, but typically that's the unknown variable because it would be on the opposite side. So we would have 7 cars equals, and we don't know how much money yet, but the book will tell us, and it says $210. So we find out that by washing cars for $7 each, they make $210. So our unknown is the number of cars they wash. Here, John makes $12.50 an hour gardening. He earned $275 this week. Solve it and find out how many hours he worked. What's the unknown in this case? What is the information we don't know? Perfect, Fernando pointed out. It's how many hours he worked. Most times with these questions, you'll see the word how many, how much, what did, stuff like that. You'll see these question words. You know, the who, what, where, when, why, how. Those are a good indicator that that would be what the unknown is. However, it still would be the unknown here, because look, he makes $12.50 an hour and he earned $275. So the thing that we would still be looking for, the only thing we don't know, is how many hours he worked. So that would be something we don't know, how many hours he worked. So what if I wanted to write this as an equation? So I want to write this. How would I write that down? So Fernando did really well. He said 275 divided by 1250 equals our question mark. And yeah, that is correct. But that's not how we write out equations. So when we write it out, he earned $275. We literally just go through and do it exactly. So he makes $12.50 every hour. So we multiply that times the hour. And that's equal to how much he made, $275. Now, here is where Fernando is correct. Exactly. Because what did he do? What did he do when he gave us this? When Fernando said equals the question mark. That's exactly what he did. What step did he do there, actually? Can you tell me what step he did? What Fernando did as he answers is he isolated the variable, because now the variable is all by itself on this other side right here. So if we watch how Fernando did it, so this is how he did it. We want to get this H right here all by itself. We want to get that because we want to get H equals. That's telling us how many hours he worked. H equals. But how do I get that H by itself? I've got this 1250 times H here. How do I get rid of that 1250 times H and just leave it at H? How do I do that? I'll give you a hint. Like I said, we have to get rid of this 1250 somehow. It's being multiplied by the H. So how am I going to get rid of it? If 1250 is being multiplied by our variable, how do I get rid of that 1250? What do you think I do to it? What operation? Izzy, what do we do?
So since there is a division symbol, we are going to divide the 275 by
1250. Yeah, so you're right. Now, it's not that there's a division sign, because this is Fernando's equation right here. But as Fernando wrote, he's completely correct. You divide on each side. Because, so Fernando said that we divide on both sides. And we do that because what we do on one side,
We do to the other.
yes, and just as a side note, what we do to the top,
We do to the bottom.
excellent, you guys. Excellent at that. So, when we do this, we have to do the same to both sides. I want to get this h by itself. It's being multiplied. So I'm going to divide both sides. You can write it like divide 1250, but the easiest way that I like to write it is simply like a fraction kind of divide. 1250, and what you do to one side, you do to the other. And that's because you see how I've got that equal sign? So they got that equal sign, meaning it's completely equal. So here, 1250 divided by 1250 is 1. So 1250 divided by 1250 is 1. That means it goes away, and I'm left with 1h. 1h. 1h is just h. 1 Isabella is just Isabella. 1 Ms. Diaz is just Ms. Diaz. So then I have to divide that 275 by 1250. So what's 275 divided by 1250? Thank you, Ani. Thank you, Nathan. Ani, Nathan, Izzy, they answered it is 22. In this case, it's simple division. I don't mind if you use a calculator on this because you need to know what steps to do. Now, that's how we identify an unknown. Let's look if I had this problem right here. So I have a problem that looks like this. D divided by 7 equals 6. Now, a lot of you know this right off the top of your head, but we need to show our work for this. We need to know how to solve this. We need to show our work, okay? So, you also might see this exact problem written. I just want to tell you these are the exact same. D over 7 equals 6. In fact, I prefer the second way, but they mean the exact same thing. That line right here, remember we talked about it, means divide. So, the next thing I need to do is we were looking here, identify the unknown. Then we would write the equation as we did. Or we don't necessarily need to write it, but that would be our next step. Then we need to isolate the variable. And then we are done. So, that is how we solve equations. So let's see. Here's my thing right here. We know our variable. The variable is D. Doesn't matter what D is, our variable is D. But what's the first step that I need to do here? What is the first step that I need to do? So we identified the unknown. We already know that it was given. Write the equation was given, so we need to isolate that variable. How am I going to isolate that variable? What am I going to do to this equation to get it down to D equals some number? So the answers I got flip, divide, multiply. When I answered divide, someone told me that it should be 6 divided by 7 maybe, stuff like that. Now, she was critical thinking there where she's saying, oh, we're dividing by 7 on this side, so we'll divide by 7 on the other. However, it's only when we physically manipulate the equation, aka when we do something to one side, that's when we do something to the other. So we have someone else's divide 7 by 6. Once again, it's not going to be divide, though. I'll give you that hint. So it's not going to be divide. It's going to be multiply. Why do you think it's multiply? This other one right here, as we saw before, this was divide. Then why isn't this one divide? Why is this multiply? This one was divide. Why is this multiply? So Rafi says you multiply 7 by 6 and you get the answer yes. Now, I'm going to explain why we know that. We do the opposite of this sign. So whatever's happening here, we do the opposite. So D is being divided by 7, so I'm going to multiply each side by 7. And look, times 7 is equal to times 7. Same on this one right here, it would work. Times 7 because it's a fraction. times 7. Both are equal to one another. What that means is that goes away. 7 divided by 7 is 1. So then we would be left with 1d, which that is just d. You only have one of them. And then we solve the other side. 6 times 7, we get 42. What if I had one like this? D plus 3 equals 9. All of us can do this in our heads in about 4 seconds at most. But that's not how we do it. We need to learn how to show our work for these. So, what am I going to do? So for this one, I multiplied. For this one, I divided. What am I going to do with this one? So Emmett says subtract. So, as we said, Emmett said subtract. We got someone who said add. Izzy said take away 3 from 3 and 9. That's great because here's the thing. We're doing the opposite of whatever that sign is. The opposite. So that would be subtract. And then we just do that same number. Minus 3 is equal to minus 3. What we do to one side, we do the other. 3 minus 3 is 0. So now we have d plus 0. Or just d. Because anything plus 0 is itself. And then we have 9 minus 3, and we get 6. This one's an easy enough problem, but we would check it if we wanted to check our work, because in the future, you want to make sure you check your work. I'd plug it in. So I put 6 plus 3 equals 9. 9 equals 9. Awesome! We got the right answer. Because sometimes you might make just a tiny computation error, and it would be something that doesn't work. What about this one? D minus 7 equals 12. What am I going to do for this problem? D minus 7 equals 12. How do I show my work? 3 of you, I got Emmett, Izzy, and Nathan all said you add 7. Yes. So we're going to add because it's the opposite. We just take that same number, 7, and what we do to one side, we do to the other. Ani also contributed with addition. Yes, thank you guys. This works. We cancel this out. We cancel 7. Negative 7 plus 7 is 0. It goes away. So it's d minus 0, or just d. Then 12 plus 7. We simply add, and we get 19. Then I'd want to check my work, because sometimes, mind you, addition subtraction's easy. But now I put it. 19 minus 7 equals 12. I check my work. 12 equals 12. Excellent. I'm good. That's great. So now I just want to review this again really quickly. I want us to review combining like terms. So I'm going to give you guys some things and you're going to combine them, okay? So the first equation is going to be, or technically the first expression is going to be this. An expression means it doesn't have an equal sign. We're not going to get a number as a result. We're not going to get, so an equation, by the way, just isn't a difference. This is good to know. An expression means you still have variables. There is no equal sign. An equation, you solve for the variables, and as you can guess, it has an equal sign. That's why it's called an equation, because it's got that equa for equal sign in it. So combining like terms, these ones are expressions because we don't necessarily have the answers for it yet. So I'm going to do this. 7 minus 2x plus 3y minus z plus 2x minus 3y plus z minus 7. So I want you guys right now to combine these like terms and tell me when I combine them, what do we get? I like to do this where I'll highlight, I'll circle, I'll underline, I'll do something, the same terms. So we're going to see this. I was given 2 answer choices, 14 minus 4x plus 2z or 14 plus 4x plus 2z. Let's see if these are correct. So the first thing I'm going to do is I like to identify my like terms immediately. Here's this. This is a number. Its like term must not have a variable because it does not have a variable. So its like term is this one over here. But what do we see about those two like terms? Remember, you had to pay attention to something. We had to pay attention to the operation. So what do we notice about those two terms? They cancel out. So Izzy has changed her answer, and she thinks that we're going to get rid of that 14. So 7, I'm going to rewrite it. So I've now got 7 minus 7. I'm going to keep going. Let's go to our next one. Here, I've got negative 2x because I need to care about the operation before it, and I have positive 2x. So I'm going to keep rewriting that. Negative 2x plus 2x. So you have to pay attention to the operation in front of it, right? So now Izzy has decided to cancel out that 4x and left us with 2z. So let's see, our next one that we have here, we have plus 3y minus 3y. Like I said, we always need that operation. So plus 3y minus 3y. And then lastly, we have minus z plus z, minus z plus z. So let's look at all of these. Let's go down. 7 minus 7, that's 0. Negative 2x plus 2x, that's 0. 3y minus 3y, that's 0. Negative z plus z is a big old whopping 0. That was a trick one. But let's try another one. Let's do another one that's not going to be as crazy cakes, okay? So what if I had this one? If I had 3x plus 2y minus 6 plus 7x minus y. So here's my equation that I've got right there. Now, I want you guys to look at the like terms, okay? I'm going to ask you individually, like I'm just going to ask you, let's go through. 3x. What is the like term for 3x? Do we have one? What is the like term? Make sure you include the operation. What is the like term for that 3x? So what's that like term for the 3x? Izzy says it is 7x. Exactly. It is that positive 7x. So the next one, what's the like term for positive 2y? What's the like term for that? And Ani put that too. So Emmett says it's y, Jasmine says it's y, Izzy says it's y, Ani says it's y, Hannah says it's y, Jenna says it's negative y. Jenna is correct. You keep forgetting you have to include the operation that comes before our letter, our variable, any sort of thing. And then what's the like term for this? Negative 6. What's the like term? Izzy goes, no. Correct. There is no like term. Our first hint is, hey, we've already underlined everything. Our second hint is that there's no other numbers without a variable. So then we need to combine our like terms. Like I said, you have to include the variable that occurs before, or you have to include the operation that occurs before the variable that occurs before the term. So 3x plus 7x is 10x. 2y minus y is y. Negative 6 is just negative 6. So as Izzy had written earlier up at the top, it is exactly 10x plus y minus 6. Let's do one more of these, okay? I want you guys to do this one. 4x minus 4 plus 4y minus 2x minus 6y minus 3. So I like this one because it's got a lot of minuses. We got a lot of negatives here, okay? So we're going to combine the like terms, and then we'll go over it at the end. So we've been given 3 different answer choices right now. They're all fairly similar, but we'll see what happens. So let's look at our like terms. 4x. What is the like term for 4x? So type in the like term for 4x. Perfect. Izzy, Emmett, I see more people typing, say it is negative 2x. Excellent. So 4x minus 2x gives us 2x. So far, all three of them got that correct. So we're all good there right now. Check, check, check. Next one. This like term, you must pay attention, is negative 4. What's that like term for that negative 4? Excellent. Look, you guys are picking up what I'm putting down. Negative 3. And then lastly, I also just want to acknowledge positive 4y. What is the like term for positive 4y? What is that one's like term? Excellent. My participating students, I have Emmett, Izzy, and Ani all say it is the negative 6y. So excellent. They all have like terms. We can combine them. So let's see. Now we have 4y minus 6y. 4y minus 6y. What is 4y minus 6y equal to? So far, 75% said 2y and 25% said negative 2y. It makes it sound a lot bigger, but 3 people said positive 2, and 1 person said negative 2. Let's think about it. If I have $4 and I spend $6, am I left with $2? No, I owe $2. So if I have 4 and I take away 6, I end up with negative 2y. So I end up with the negative 2. Whenever a smaller number is taking away a bigger number, you always get a negative. So think about that. If it's a smaller number taking away a bigger number, you get a negative. If it's a bigger number taking away a smaller number, you get a positive. So now we get negative 2y, which means that for these ones, this and this have so far passed our test. Uh-oh, that one's out of the running. And then last but not least, let's combine our numerical like terms. Negative 4 minus 3. What's negative 4 minus 3 equal to? Negative 4 minus 3. We got 2 answer choices. We got that negative 1 and we got that negative 7. Let's see. If I'm doing this, if I owe $4 and then I owe $3 more, I owe a total of $7. So the trick at this one, the one that you guys had made a mistake on, is that you weren't counting that negative in front of the 4. You had that 4 minus 3, you got 1, but because you saw that negative there in the first place, you had decided, okay, so it's going to be negative 1. But borrow and borrow always get more borrow. Borrow, borrow, more borrow. So for example, if we're doing this, a subtract, if I do this one, like if I had a negative and then I subtract a number, I get more negative. If I have a positive and I add a positive number, then I get more positive. And it just depends. For example, if it's a bigger negative and then we're taking away, then we get the negative. It's all sorts of stuff like that. But exactly. So our correct answer here, as we get negative 7, is this, as Jenna did it. Now, it can be written several different ways. One of the things that you can write it in is, if I was to erase this, any way works as long as you contain those numbers and those operations. So another way to write this would be 2x minus 2y minus 7. That's the way I tend to like to write it, because you want to write it x, y, and then our number or whatever. But it could also be written as negative 2y minus 7 plus 2x. It could be written as negative 2y plus 2x minus 7. It could be written as 2x minus 7 minus 2y. All of those are the same thing because they all contain the same numbers and the same matching operations. The last thing we're going to review is factoring and distributing. So to factor, we use a greatest common factor. Makes sense. We see that word factor. For example, if I had 12x plus 6, the greatest factor they have in common, if I'm going to factor these, I get 1, 12, 2, 6, 3, 4. 6 gets me 1, 6, 2, 3. The biggest number they have in common is that 6. As we see, the matching number across is what I get at the end. Look at that. So when I divide by 6, I pull out that 6. I get pulled out that 6. 12 divided by 6 is 2, but we still have that x. That x stays. 6 divided by 6 is 1. So that is how we get that. What if I had something that looked like this? 5x plus 20y. I want you to factor that for me. What is the greatest common factor for 5x and 20y? It is 5. So they both can be divided by 5. Let's bring that out there. So I pull out a 5. 5 divided by 5 is 1. So I'm just left with that x. 20 divided by 5 is 4. And I'm left still with that y. So that's my answer. What if I had one like this? 5x y plus 10 xy plus 15x plus 20y. So this is a tricky one, okay? First of all, what's the greatest common factor? So excellent, that greatest common factor is 5. 5, 10, 15, 20, all divisible by 5. So I got to pull out that 5 again. And I'm now left with xy plus 2xy plus 3x plus 4y. Because these two have matching variables, but the others don't. So I can't pull it out. What if I had this one? Okay? If I had 5x plus 10x. What is that greatest common factor? Think about this. What is that greatest common factor? So you guys have answered 5, and it's close, but what else do they have in common? What other number between them do they have in common? It might not be a number. That's a good hint. Exactly. Fernando, Nathan, and Emmett said X. All of the terms that we see here have an X. Lila said X. We see that. So we pull out that 5X because they both can be divisible by 5 and both can be divisible by X. 5X divided by 5X is 1. 10X divided by 5X is 2. Right? There we go. Let's check our work because I want to show you the distributive property now. These are like terms at the top, right? 5x plus 10x. What is 5x plus 10x? What does that equal to? Excellent. Izzy, Rafi, and Ani tell me it is 15x. Perfect. Just as simple as combining like terms. Do not make it 15xx. Do not make it 15x squared. These x's, they are only counted once because it's kind of like 5 Devons and 10 Devons is a total of 15 Devons. You get what I'm saying? It's addition, so we're not adding them anymore. Let's check this. I want to solve this problem. What this is it's 5x times, in parentheses, 1 plus 2. So I follow PEMDAS. I'm not trying to solve for the variable, as we see, and so I follow PEMDAS. I'm not trying to solve for the variable. I'm just trying to get an equation. So the first thing I get, 1 plus 2 is 3. And I've got 5x times that. What I'm doing is I'm distributing that, right? What is 5x times 3? Who can tell me 5x times 3? Exactly, it is 15x. Perfect. Again, we're getting that same thing. We checked our work. What if we did it like this? If we did that 5x times 1 plus 2. If I distributed it over here, again, I would get 5x plus 10x equals 15x. Last problem I want us to do is this. 2x, 5 plus 7y. This is tricky, okay? But we need to distribute it. I can't do anything in this parentheses. They are not like terms, so I can't do anything. So my parentheses are already done. I can't do anything to them, so they're already done. Exponent, There is no exponent. Multiplication division. We do have some multiplication division. So I need to multiply this 2x. What am I multiplying that 2x to? What is the number and or numbers I am multiplying the 2x to? I am multiplying it towards everything in the parentheses. So I like to draw my arrows so I don't forget. It's 2x times 5, and then it's also 2x times 7y. Exactly. So as Izzy said, she said 5 and 7y. 2x times 5 is 10x. This one's trickier. What's 2x times 7y? What is 2x times 7y? So I've got some different answers here. I got a 14x. I got a 14xy. It is 14xy because x times y is just xy. We don't know what they are yet. So what I get is 10x plus 14xy. Again, I could pull the x's out of these because they all have it in common. In this earlier one that I was doing where we couldn't necessarily pull it all out, this has an x, this has an x, this has an x. Oh, no x. That's not the greatest common factor. This has a y, this has a y, this has a y. Oh, no y, no greatest common factor. However, let's say I got rid of that one. Right there. Boop. Ended there. Now, my greatest common factor would be 5x because each of those numbers inside have an x. So I divide by x, it goes away. I divide by x, it goes away. I divide by x, it goes away. There we go. Let's say if I was doing something else cool. Let's say this one was 15x squared, right? So here in this case, when I divide by x's, if I divide by my x's, my greatest common factor is 5x. So I pull out my 5x. Let's do that for each one. So 5x. 5xy, I'm left with y. Plus 10xy, I'm left with 2y. Plus 15x squared, I'm left with 15x. Because x squared divided by x equals x. X squared is x times x. Divided by x equals x. I know that's a lot of sentences. X times x divided by x equals x, but it's true. 2 times 2 divided by 2 equals 2. 7 times 7 divided by 7 equals 7. That's how it works. So that's what I would get in this end here. And I could combine these like terms as we see. We would do all of that. So that is how you do distributive property, and that is how you do factoring. That's it, you guys. Congratulations.